Hello everyone, my name is Dr. Jyoti Tiwari and I'm a postdoctoral fellow in the Department of Earth Sciences at IIT Bombay, working under the supervision of Professor Somajit Mukherjee. Today I'll walk you through the types of geohazard, its causes, impact, and some notable case studies from India. And we'll also highlight the fact that how we as a scientist and society can better prepare and respond to these geological hazards. What is a natural hazard? A natural hazard refers to a potentially damaging natural phenomena. These are events that may occur in a defined geographic location within a specific period and can lead to damage or destroy infrastructure, people, or the economy. It's important to understand that not every hazard turns into a disaster. It depends on exposure and vulnerability. Natural hazards are classified into two types, climatological and geological. Climatological hazards include droughts, heat waves, cyclones, floods, and hailstorms. These are largely driven by weather conditions such as precipitation anomalies or extreme temperatures. Geological hazard, also called geohazard, includes earthquakes, volcanic eruptions, tsunamis, and landslides. These are rooted in the dynamic processes of the earth crust but can also be influenced by the climate. What is a geohazard? The term geohazard is a contraction of geological hazard. It refers to natural earth processes or conditions that pose a threat to life, infrastructure, or the environment. Classic examples are earthquakes, landslides, sinkholes, and tsunamis. Definition of geohazard by Lee and Griffith 2024 is geohazards are the geological processes or conditions that can be a source of risk. These geohazards can be due to a geological condition or some geological processes. They may arise rapidly, like a sudden earthquake, or they may be slow, like ground subsidence. The critical aspect is that risk is amplified when human activity intersects with these hazard prone zones. As Lee and Griffith noted in 2024, geohazards are risks emerging from both natural and human induced geological processes. The article Structural Geology in Active Tectonic Regime and Introduction by Mukherjee et al. In 2025, published in Journal of Structural Geology, tells us how ongoing crustal deformation shapes our landscape. This includes processes such as fault reactivation, uplift or subsidence, tilting, and the build-up of seismic strain. The geological processes have significant impact. For instance, in tectonically active zones, crustal deformation ensures slope instability and can disrupt drainage system, leading to an increased risk of both landslides and floods. Why active tectonic must guide geohazard assessment? This table, sourced from Mukherjee et al. 2025, outlines how different researchers have defined active tectonics. Despite some variations, there's consensus that understanding ongoing tectonic activity is vital for hazard assessment. Ignoring structural imprints like faults or lineaments in hazard mapping can lead to underestimation of future disaster risk. Let us see some case studies of geological hazard from India. These are the locations of geohazards in the Indian map that I'll be talking about in this presentations. Urban flood, Chennai 2015. In November-December 2015, record-breaking northeast monsoon rain caused massive flooding in Chennai. Reservoirs and the rivers in the nearby area overflowed. Low-lying areas were inundated and over 400 lives were lost. Approximately 3 million people were affected from this flooding. Also, infrastructure was damaged. Rapid urbanization and the encroachment of wetland worsened the situation. Kerala floods and landslides of 2018. Exceptionally heavy rainfall from June to August in 2018 led to the overflow of several rivers in the state. This triggered over 340 landslides in the ecologically fragile Western Ghats. This event led to 433 deaths and the displacement of more than a people in the state. Next is Cyclone Fani in Odisha 2019. A devastating cyclone struck Puri with wind reaching 200 km per hour and significant storm surge. Thanks to early warning, a massive evacuation helped limit fatalities to 72. However, infrastructure damage was immense, affecting half a million homes. Also, India suffered huge economic losses due to this cyclone. Earthquake swarm of Palghar 2018 and 2019. Over 1,000 tremors occurred in Maharashtra's Palghar district from November 2018 to February 2019. The magnitude of these tremors were from 1.5 to 4. It was far away from any major fault zone. However, no major earthquake occurred, but many houses developed cracks and some structural damage. This intraplate activity was possibly due to triggered by some seasonal monsoon water that percolated into the deep fractures. Talia landslide of 2021, triggered by extreme rainfall, a massive landslide in Talia village buried 32 houses and killed 84 residents. A rain-soaked hillside collapsed without any warning and burying the village below. It was a series of landslides. This tragedy spotlighted the vulnerability of hillside settlements. Wayanad floods of 2018. In August 2018, in just a single day, Wayanad received 305 millimeters of rainfall. The overall rainfall in the district was above 23.5% from the normal. The excess precipitation caused widespread landslides, displacing thousands and severely damaging infrastructure. Bhuj earthquake liquefaction Bhuj earthquake liquefaction of 2001. The magnitude 7.7 earthquake caused massive liquefaction near Bhajau, Kutch, Gujarat. It was a salt plain with high water table. Strong seismic shakes were observed. Bhajau, Anjar, and Rapar town were impacted. Salt flats remain highly susceptible due to ground failure. Several thousands of households were displaced, and reconstruction became a challenge due to unstable ground. Sand boils, ground fissures, and lateral spreading were also observed in the area. Ground subsidence led to ground tilting and collapse, damaged buildings and roads. It led to the urgency for understanding the importance of land use regulation in liquefaction prone areas and also how important a strong foundation design is and highlighting the importance of integrating liquefaction into seismic microzonation studies. Monsoon floods of 2014. It was a pan-India event. This event affected multiple states of Northeast and South India, with causing 1,878 fatalities and over 351,000 displacements. Assam, Kerala, Gujarat, Tripura saw heavy impact, often linked to compounded effect of climate, infrastructure weakness and poor planning led to this pan-India event of monsoonal floods in Northeast and South India. India has many eminent researchers contributing to geohazards. Dr. C.P. Rajendran, adjunct professor at National Institute of Advanced Studies, Bangalore. Dr. D.P. Kanago, chief scientist and professor at Geotechnical Engineering and Geohazard Department at CBRI Roorkee, and Dr. Himanshu Mittal, Scientist E at National Center for Seismology at Ministry of Earth Sciences, are some notable contributors. There are many other scientists as well as researchers who are working on geohazards in India. These are just few. Along with them, there are some structural geologists such as Professor Soumyaji Mukherjee, who has been undertaking multidisciplinary research to address natural hazards. Professor Mukherjee integrates structured geology with slope instability analysis. His study uses stereonets, slope mass rating, and paleostress inversion to identify risk-prone areas. His work integrates structured geology, remote sensing, and geospatial analysis to better understand slope instability and terrain deformation in hazard-prone areas. This article, published in the year 2025 in Structured Geology by Punya et al., titled Morphotectonic slope stability and paleostress study from the Bhagirathi River section, Western Himalaya, Uttarakhand, India, has studied 24 landslides and 11 slope section in Bhagirathi Valley. The basin was divided into three zones, K1, K2, and K3, and the fault data and Sneaken lines were collected from these zones. Kinematic analysis via StereoNet revealed the dominant failure mode if it was a planar failure or the wedge failure. Similarly, this article by Satishwa Chatterjee et al. Published in Evolving Earth in 2024, titled Morphometry and Active Tectonics of the Konkan Coast, Western India, tells us that landslide susceptibility is influenced by not just tectonic but rainfall and some anthropogenic activity. That is, extreme monsoon and rock type, slope angles, and human activity can too lead to landslide. This multidimensional nature making geohazard forecasting complex and necessitates interdisciplinary methods. Now, role of AI in geohazard. AI is transforming hazard science. Machine learning models now outperform traditional meteorological simulation for rainfall and drought forecasting. In disaster response, there are many that assist in mapping earthquake and wildfire damage. AI also enables impact based forecasting by linking weather data with socio-economic outcomes. Now, some disaster response like BDNet and Fire CNN are the ones that may assist in mapping earthquakes and wildfire damages. Early warnings are being customized using mobile apps, satellite feeds, and social signals. Deep learning allows simulation of what if scenario, helping agencies plan evacuations or resource deployment. For further reading, there are some books that I would recommend. These are the name of the books. I would like to go through a preface of these books for just information. First is Geohazard, Natural and Man-Made. This volume explores the complex interaction between natural processes and human activities. Hazards like earthquakes or floods are natural, but human factors such as poor planning, overpopulation, and environmental mismanagement transforms them into disaster. The text warns us that we are not just observing nature force, we are intensifying it. It also urges us to focus on real existential threat like climate collapse and ecosystem failure rather than media fooled doomsday. Earthquake safety is a key theme where existing knowledge isn't matched by preparedness. The solution, education, social responsibility, and resilient infrastructure. Next is earthquake hazard, risk and disasters. This work highlights how natural seismic and volcanic hazards are exacerbated by human behavior through deforestation, dense settlement, and poor construction. It pushes for interdisciplinary collaboration combining geosciences, engineering, and social policy. It warns that people fear exaggerated threat, real risk like ground shaking and volcanic eruptions are often ignored. The message is clear: invest in education, evidence based policies, and public awareness to reduce risk. Next is landslide hazard and risk. Landslide research has matured across two scales: site specific studies focusing on slope mechanics and regional assessments using GIS and historical data. The book goes beyond the physical science, exploring economic and psychological impacts as well as economic coping strategies. It covers five key areas from risk model to real world solution. Tools like INSAR and global case studies show that progress in landslide forecasting while stressing the values of multidisciplinary teamwork across engineering, law, and sociology. Next is volcanic hazard, risk, and disaster. Volcanoes may seem distant to many, but this volume takes clear that their impact through ash clouds or lava flows can be global. It revisits the link between human settlement and volcanic danger, often due to fertile soil or tourism. Japan is highlighted for its disaster readiness, suggesting that more nation needs early warning systems and public education. Volcanic risk is everyone's concern, from villagers on the slope to travelers in the sky. Seismic hazard and risk analysis. This monograph is a practical guide for geoscientists and engineers, especially those involved in probabilistic seismic hazard analysis. It assumes some knowledge in probability and ground motion but focuses on real world application, encouraging professional flexibility over rigid methods. It stands out as a hands on manual useful for informed decision making and seismic risk mitigation. Next is disaster management in the complex Himalayan terrain. This book focuses on the Himalaya, where hazards like floods, earthquake, and glacial lake outburst intersect with steep terrain and population pressure. Using remote sensing, GIS, and case studies, the book integrates science with sustainable policy. It underscores the need for forecasting innovation such as potential earthquake prediction and argues for balancing environmental protection with infrastructure development. Natural hazard uncertainty assessment, modeling, and decision support. This volume emphasizes a global shift towards disaster risk reduction, especially in vulnerable regions. It stresses early warning system, clear science policy communication, and grassroots involvement. It promotes a collaborative approach involving both experts and citizens, particularly as climate related disasters grow more severe. The message is one of empowered through applied science. Next is reducing disaster risk by managing urban land use. Produced by the Asian Development Bank and UNDRR, this guide shows how urban land use planning can serve as a tool for disaster risk reduction. It highlights developmental control zoning and redevelopment as mechanism to build safer, more resilient cities. Case study shows how smart land management has already reduced risk in real urban settings. Disaster Risk Management System Analysis. This text built on the HIGO framework for action calling for proactive GRM through preparedness, prevention, and institutional coordination. It highlights the need to link GRM with climate adaptation, especially in agricultural dependent nations. FAO offers practical tools to assess institutional readiness and strengthen national disaster framework adaptable across sectors and regions. Natural Hazards and Risk Mitigation in the Himalaya. This book compiles the latest research on Himalayan hazard with a focus on seismotectonic, landslide, glacial risk, and slope stability. Many studies using tomography, INSAR, and GPS to understand crustal deformation and ground movement. Key findings suggest that active zones are partitioned, potentially preventing megaquake. Papers also touch on heritage structure safety, liquefaction, and multidisciplinary strategies. This volume is especially valuable for those working on risk mitigation in high mountain events. Now, also there are some many journals that can be used to publish a work on geohazard or to read about geohazard. These are natural hazards, landslides, engineering geology, geomorphology. Also, there are some specific to some hazards like for earthquake and seismic hazard. It's Bulletin of Seismological Society of America, Seismological Research Letter. For volcanic hazards, it's Journal of Volcanology and Geothermal Research. For hydrometeorological or flood hazard, it's Journal of Hydrology and Earth System Sciences. Regional focus and policy interface, it's International Journal of Disaster Risk Reduction and Geoenvironmental Disaster. Other than that, these are some other articles, journals that can be used for geohazard publication or reading about geohazard. First is Geohazards. It's for general geohazard, including some case studies, GeoRisk, that is for quantitative risk modeling for geohazard. Natural Hazard Review, that is for engineering perspective of natural hazard. Geosciences, it covers geohazard among broad topics. Frontiers in Earth Sciences, Geohazard section, that is for modern and interdisciplinary research. These are the references that has been used for this studies. Thank you so much. At last, I would like to conclude that geohazard represents convergence of natural hazards and societal vulnerabilities. With climate change, urban expansion, and tectonic activities playing a key role, our strategies must evolve through scientific research, AI tools, and proactive governance. Thank you for your attention. I'll be happy to take any questions. Hello everyone, my name is Dr. Jyoti Tiwari and I'm a postdoctoral fellow in the Department of Earth Sciences at IIT Bombay, working under the supervision of Professor Soumya Mukherjee. Today, I'll walk you through the types of geohazard, its causes, impact, and some notable case studies from India. And we'll also highlight the fact that how we as a scientist and society can better prepare and respond to these geological hazards.